Now we want to look at graphs of polar equations. And with graphs of polar equations, we're going to go through the process that you did with rectangular equations. With rectangular equations, when you first started graphing a line, you made an XY chart where X was 0, 1, 2, 3, 4. And then you plugged that 0, 1, 2, 3, 4 into your original equation and you got your Y out. And then you had an XY ordered pair that you graphed. Same concept is going to be true with polar equations. But instead of having an XY chart, we are going to use a theta R chart, where we get to choose the theta, or the angle measurement that we're going to work with, and then our output is going to be the R. Once we've got that, we'll then plug in our different values on our graph. So here you can see I've got the polar equation, R equals 2 cosine theta. And what we're going to do is we're going to take some known values from, in this case, the unit circle, pi over 6, pi over 3, pi over 2, and we want to find out what the corresponding R values are going to be. So just as you did with a straight line or a parabola early on, you're going to plug this angle measurement into your formula. So to start off, R equals 2 times the cosine of 0. And we know the cosine of 0 is 1. 1 times 2 is 2. So my R value is going to be 2. Here, we'll do 2 equals 2 times the cosine of pi over 6. Now, since we don't have square roots here on our graph, we're going to be using decimals. We can use the decimal equivalent so we've got a better idea where the graph is going to go. So 2 times the cosine of pi over 6 is going to be 1.732 if you plug that into your calculator. Then you continue along. R equals 2 times the cosine of pi over 3. We know pi over 3 is 1/2, and 1/2 times 2 is 1. So pi over 3 would be 1. R equals 2 times the cosine of pi over 2. Pi over 2 is 0, so the cosine of pi over 2 is 0, I should say. 2 times 0 is 0. And you do the same thing for all the rest of those angles, plugging in pi over 3, pi over 6, pi, and getting your equivalent R values. So let me just fill these in. 2 pi over 3, when we plug it in, will end up being -1. -1.732. When we're at 5 pi over 6, pi will be -2. 7 pi over 6 is once again -1.732. 3 pi over 2 is 0. 11 pi over 6 is 1.732. And then 2 pi is going to be 2. So now that I've got all those values filled into my chart, I can begin plotting them. So now we've got to think about this in terms of polar plots. We first are going to turn to the angle that we're at, and then we're going to move the number of units out that R is. So right here we'll start with the angle of 0, and the angle of 0 is 2 units out. So if I'm facing the 0 degrees, which is this, in this case, to the right, I'm going to go out 2 units. So my first ordered pair is going to be right there. That's 0. That's actually 2, 0. Remember, when you write the ordered pairs in polar coordinates, the R comes first. The second one we've got is this pi over 6 and 1.732. So we need to draw in our pi over 6 line. So there's pi over 6. And if I continue this line back in this direction, that ends up being our 7 pi over 6 line that we'll use a little later. So here, if I'm facing this pi over 6 line, I'm now going to go 1.732 units out. So I'm almost out to 2. Next one we've got is pi over 3. Here's pi over 4. We know pi over 3 is around here. And I'll continue it back there, which would be our 4 pi over 3. So there would be the pi over 3, and then actually I don't have any 4 pi over 3, so I'm not going to worry about the back side. But pi over 3 we know is 1 unit. And then we go to pi over 2, which is 0. So if I'm facing up, I'm right at the origin again. Now if we go to 2 pi over 3, which we know is about right here. I know this line continues back like so. When I'm facing 2 pi over 3, I've got negative 1. So if I'm facing this direction, I've got to go back 1 unit. At 5 pi over 6, which is about right here, here's 5 pi over 6. And I know it's going to extend in the exact same direction that way. So 5 pi over 6, I'm at a negative 1.732. So facing this 5 pi over 6, I'm going to walk backwards 1.732. And then if I'm at pi facing this way, I'm going to go back 2 units. So I'm back to my starting point. And if I were to continue along, those other points would already be filled in for me. So my graph is going to look something like that. Not quite drawn perfectly. It should be a little more circular with the shape if everything were drawn correctly. But that's the way you would go about drawing your graph in polar coordinates, taking your r, theta values and plotting them. Now what we're going to do is we're going to do a lot of work on the calculator. So let's just confirm that this picture looks semi-close to what it should be. So I got my calculator here. And let's make sure our mode, we want to be in polar mode for this. So I'll head over to polar. And in my polar box, I'll put 2 cosine of theta. And I'll graph it. Sure enough, it looks like I've got that circle shape right there. I can always do a little zoom in just to confirm, and sure enough, that's sort of what I've got right there, a circular shape off and to the right. Remember, this one looks a little more oval shaped because there's more x pixels than y pixels, so we get stretched in the x direction. If I want to see a more accurate picture, I could go to zoom square, and then that evens out the x and the y pixels, so I can see there's more of the circle that I was looking for.